and that turns off the device by sending the control device request to my FastAPI server now, right? And now let's go over here and turn the device back on. And I'm going to hit enter, and that turns on the device. Okay. Hey everyone, welcome back to my channel. If you're new here, I'm Mukul. I'm a software architect by profession, and today I'm super excited to share some amazing new features that I've added to our FastAPI server. In my previous video, I showed you the concepts of API first approach and why we've chosen that to build our speech-to-speech implementation of Jarvis. And today I'll show you how easy it is to add new features to such an implementation. So I want to show you how we are going to add a TP-Link Casa library support, which is for home automation, to our FastAPI server. And in order for me to do that, let me first walk you through the architecture diagram changes that we have. So you've seen the diagram very similar to this yesterday or in the previous video. And today we are adding these three endpoints to our FastAPI server. And these three endpoints will be to discover devices in a home. So in my smart home, I have a ton of devices that are operated by Wi-Fi. And these TP-Link devices are actually pretty cool. They do not need any special hub for operation. So if you are trying to implement a home automation system, I highly recommend using TP-Link Casa, because you can directly operate without the need of any external key, even if you do not want to have an external API, right? So all these devices kind of stay inside your home. You don't even need to have a Wi-Fi that is connected to internet for this to work. Even if your internet is out, these devices still work. So that's why I really like the TP-Link Casa approach of doing it. You get a local IP address assigned, and you can access your devices by local IP address. And we'll see all this in a few minutes. But what I want to highlight is that these three endpoints, discover devices, list devices, and control devices, these three endpoints will be built today, and we'll use TP-Link Casa library, Python Casa library for doing that. So let me first show you my approach. How do I attack such a problem? So anytime when I want to build something like TP-Link Casa support, I try out their library first. So let me show you. So let me open up TP-Link Casa's simple main program, right? So what I'll do is I'll first import the Python library for Casa, which is Python Casa, and I'll just make a simple blank new project, right? So just made a project called tool test, put a requirements.txt over there, any requirements that are required for the project. In this case, it's just Python Casa, and we'll just get that in. Then in our main .py file, I just do a very simple use case. Hey, just discover the devices, right? So it's a very simple use case, discovering the devices. And let me show you this, or we can just actually run it straight from here too. So let me get the terminal out. And toolset is our Conda environment. I actually wanna just minimize this and we'll run it over here. So let's do cd ... and I think it is right here in this folder. Yep. And we have our main.py file that I want to run. And I've already run the requirements.txt pip install for that. So I made an environment, Conda environment called tools test, and I'm activating that environment. So you see that I'm in the correct environment now. And let me see if I can make this console or terminal bigger so that you can watch me type with ease. So one more plus, and there we go. All right. So my very first test would be to run this main.py. So, and it's discovering the devices on my home, and it's going to list them one by one, all of them that are there, right? So I have a ton of devices, as you see, and they are individually assigned IP addresses over here. And this is what I was talking about, that I don't need to provide any kind of key. You see, there is no key, no authorization, nothing required. If you are on my local Wi-Fi, you can access this device straight up. And now let's move on. So now when the initial use case is done, I need to move on to a more complex use case, and which is over here, this Casa test.py comes into picture. And this is a bigger mammoth file, and this will need some more explanation. So you see at the start, we have some imports. I have async IO, that's used for asynchronous programming. Then JSON, obviously used for JSON data handling, and OS, which is a way for using the operating system dependent features. And you will see why we are doing that, because we are going to create a JSON file and store it on our file structure over here. Then RE provides for regular expression matching, and we are using it for using our device model names, like for example HS200, right? So I'll show you over here. When we had these device model names listed, oh, it's not listing over here, but then that's all right. I'll show you in the JSON file. But when we list down our device model name, it appends US next to it. So I'm using some regular expression over there to strip that out. And then FastAPI, obviously, it will be used. I mean, it's not being used right now, but that will be used in our FastAPI implementation. But in this implementation now, I'm using certain classes from the Casa library. So Discover, Smart Plug, Smart Bulb, Smart Strip, a generic smart device, and then smart device exception. Okay, so the purpose of this regular expression that we have over here is to strip down and remove anything that is within parentheses, and also any leading white spaces over here. And that's what I was talking about, that when we list down the devices, I just want to extract the name, the model names, like KP115 or TP200 kind of thing, right? So that's what's being done over there. So the discover devices function, so that there are now multiple functions that are built in. The very first one is discover and store devices. This function is used to discover devices and store the information in the JSON file. So what I'm doing is, when I'm running this particular application, it finds out all the devices and it stores it in the JSON file. And the way I have structured my JSON file is that if a device has HS210 or HS200, and these are the specific device model names, then it should be grouped under a light switch kind of JSON structure. If it is HS105, 115 or KP125, then that is a light switch, right? So I'm sorry, that is a smart plug. So I append it to the smart plug section in the JSON. Similar to that, KP400 and KP300. So these are like the smart strips of lights that I have at my home, where you can plug in multiple light or multiple plugs, and that are going to be categorized as smart strip. That was just the structure that I chose. And if there is anything else, I mean, I haven't found anything else yet at my home, but if there is anything else, then group it like. So this is the high-level description of my discover and store devices. And this, in the end, it creates a JSON file and stores it over there. Then I have a load devices, where you can load all the devices that have been stored in the JSON file. I don't want to scan on every single run. If I scan on every single run, it takes a lot of time to scan, and the IP addresses do not get updated as often in my Casa devices. So I can schedule loading of a device maybe like once a day, and then it can scan in the background and load the devices. You saw it takes about 3 to 5 seconds to scan And when we are having a speech-to-speech kind of interaction, even 3 to 5 seconds, which normally seems minuscule, is a lot of time when we are getting a response back from a voice assistant, right? So we don't want to do that. We want to store the device names and then just retrieve it by reading that JSON locally, right? And then there are some functions that you can perform on the device name, which is listed over here. All right. So this is a huge file to explain. But I have structured it in such a way in smaller asynchronous functions so that you can read through the code over here, and then you can understand each one of the function what it does, right? So if you go to the outline and if you take a look, there are load devices, list and control devices, and such functions over here, right? So, okay, now let me execute this, and then this will be more interesting than me just talking about the code over here. So let's run Python test.py, right? This is a bigger canvas, Casa test.py. And now this is the one code that I was showing you right now, and this is nicely formatted than last time, and it will list all the devices for the very first time because I do not have any JSON file right now. I detect that there is a JSON file that doesn't exist, so you just keep an eye on that left hand side section over there. Once the device listing is complete, a JSON file will be created. You see Casa devices.json, right? That got created over here, and all the devices got categorized into the right category. And this is what I was talking about, these model names. They do not have that bracket US next to them, right? So they are just the model names is what I wanted. And based on these model names, they have been categorized and grouped into these categories. So these are all the light switches in my home. These are all the smart plugs in my home, and these are the smart strips in my home. So I have 35 of these devices currently. I have more of them, but the others are unplugged right now, so they are not detected. They do not have IP addresses defined. I believe I have about 50 or 55 devices, such smart devices at my home. All right, let's take a look at the JSON structure over here quick. So you will see that in my JSON, we have light switch, smart plug, and smart strips. These are the 3 categories of the devices. And this is very important because when we'll go to the FastAPI section, we will see how we are utilizing these 3 categories when we are sending requests and responses to the FastAPI. But right now, we are just developing locally without the FastAPI just to make sure that this library is working. Okay, so now this program gives you an option that, hey, which device do you want to control? So let me control this office where I am. So office switch, which is device number 15 over here in this list. Let me just type number 15, and it's asking me what do I want to do with that device. Let's turn off the device, and you will see the lights over here will go off as soon as I do that. And there you go, there's darkness over here. And let me do the 15 again and turn on the device, and you will see the light comes back, right? So this is a programmatic way of interacting with your Casa endpoint. And now what we'll do is, let me quit. Let me show you one more feature over here, rerun the program, because JSON exists. All right, so when you rerun the program, it asks you whether do you want to update the device list or you want to continue with the pre-scan devices which is present in the JSON. So if you do a no over here, you don't want to update, then you can continue with the preloaded list that is coming from the JSON now, right? So let me quit this by pressing Q, and we are done with this. So we have tested all our functionalities and everything, and it's working fine in Casa test.py. How do we add such a functionality now, right, to our FastAPI server? This is the critical point over here. So let me move this out and let me bring in my FastAPI server over here. Okay, so this is what you saw yesterday, right? So there was an app in the previous video, or yesterday, same thing. So in the app folder, we had our routes.py, and in the routes.py, we had several routes that we have defined. So now we are going to add 3 more routes over here, right? What are those 3 routes? So those 3 routes are over here. So these are discover devices, list devices, and control devices. So these 3 routes we have to add over here first. And what I do is I first build out my endpoints. I just write them out, what I want to do with them. So these are the 3 endpoints: discover devices, list devices, and there are 2 endpoints in control devices. One endpoint is turn on or off the device by just the IP address, and the second endpoint is turn on or off by the category and friendly name that we have for that, right? So like office switch and light switch. So if we do not know the IP address, if we know what kind of device it is and what's the name of the device, we can still turn it on and off. And the reason why I just did not want to do the friendly name is I wanted to identify the device with a unique enough ID. So I, at my home, do not name 2 devices exactly same, but there is a possibility that I'll put an office switch named different category of the device in my office. And that is why I wanted to make sure that I listed down by category and a friendly name both, right? So there are 3 endpoints, but in reality 4 endpoints over here: list devices, control devices, and discover devices. And control devices are 2 endpoints in themselves. The requests to these endpoints are different essentially. Okay, so we can now see that we have these 3 endpoints in the FastAPI server routes mentioned over here. So let's take a look at the routes.py. So in routes.py at the bottom over here, these are the new endpoints for your Casa devices, right? So discover devices, which will list down the devices that we have, and it will put them into our JSON file, right? So in the local JSON file, it will put it down. And list devices is what will read the local JSON file and it will send it out as a HTTP response back, right? And before recording this video, I actually ran this, and that's why we have this Casa devices JSON.file already created over here. Let me delete this file so that we start from a blank slate, right? So discover devices is what was creating that JSON file in our local file system. List devices reads that file. If it doesn't find it, it raises an exception. But if it does find it, it reads that file and sends you the contents of the file. And now you have your control devices endpoint, right? So in this endpoint, you have 2 different kinds of requests that you can receive. One request is just by IP address, and second request is by category and friendly name, right? So these are the 3 endpoints that we have defined. And what happens when a route hits this particular endpoint? So that is this TP-Link Casa.py. Now let's take a look at TP-Link Casa.py. And in this file is where we are defining various asynchronous functions that get executed once we call the routes, right? So for example, there is the discover device function that gets called, and when you do call that function, you do not want the response to wait. So we just asynchronously queue it that, hey, just go ahead, start the scan process and tell the user that you're scanning it. The user doesn't need to wait for it. And that's why we have this particular asynchronous function for discover devices over here. Now to load the devices, we then get into the local file system, and that's why we have OS, and we check for the device file name, which is casadevices.json. Right? And then control devices by IP. This asynchronous function gets called when we are trying to get a control of a device by using an IP address. So there's only one parameter input over here for the IP address, and well, obviously, if you want to turn it on or off, that's also over here. And then control devices by category. And this gets called when you are having the category and also the friendly name passed along with the action that you want to take on that particular device, right? So these are the 4 methods, 4 very simple methods, right, that are defined over here. And these were all extracted from our initial casa test.py file. All right. So now that we have all this set and done, let's run this application. And in order for us to run it, it's as simple as going to our FastAPI server. So I don't need this particular one, so I will close this out. And I am in OpenVoice, so yep, this is our FastAPI server. So what I can do is, so let me do conda activate OpenVoice, go to the server. I already have this command written over here, but all you need is to do conda activate. We are already in this folder, so this command is redundant right now, but doesn't hurt us. And UVCon startup of that FastAPI server is what we need. Reload option is because if you are programming and developing, so it can do a live reload over here. So let me run this command, and it will switch the conda environment, start the server, and we will be ready for sending requests and responses to our application after this. Okay. All right, so the server is up, which is good. What we'll do is I'll make this bigger. I think I closed my other terminal that I made bigger, which is all right. I can make this one slightly bigger over here, and I'll keep this on left side, and then I'll pull up my documentation that I have for the FastAPI server, which I'll also make bigger also in a second. Just a moment, please. There we go. Okay. All right. And let's make this a little bigger. And like that. Perfect. And what we're doing is we are trying to, doesn't matter which folder you are in now, what we're trying to do is we're gonna just list devices first. And because I've deleted the JSON file, I think it should say that, hey, you need to run discovery, because you cannot list devices if I do not have them back in JSON for it, right? So that's what it said. If you see over here, we did a request and it said 404 not found, right? It is asking us to run the device discovery first before we can do the list devices. And let's do that. Let's run the device discovery first. And you see, it said that this device discovery started, check server logs for progress, right? So, I mean, we did not want for the user to wait for the device discovery, and that's the reason why it is an asynchronous process. So it says, yep, your device information is saved to casa devices.json, and we can run the list devices now, and it won't be a very pleasant output, but at least I want to show you that the list devices gives you a list of all the devices, right? So everything that here, it is being shown over here. Now, let's say if I know that what my particular device name is, right? I can either send it using this particular IP address. So let's see, this IP address, I think this is for my home office, right? So which is where I am right now. So let me just do a Control F, and you'll see that this is the office switch which we have over here. All right, perfect. So what I'm gonna do is I will now control this device by sending well, it's already on, but let's send it a off command over here, and that turns off the device by sending the control device request to my FastAPI server now, right? And now let's go over here and turn the device back on. And I'm going to hit enter, and that turns on the device. Okay, so we can see how it is nicely controlling everything using our IP address only. Now let's do another test by sending the payload as the category and friendly name, right? So let's copy this request, and this is to turn on the device, and this is to turn off the device. So let's copy the request to turn off the device because device is already on. And we'll send the request to turn off the device. There we go. And you can also see the logs that have been shown on the FastAPI server. And then I'm gonna copy the request to turn on the device and hit enter, and fail to control the device. Okay. 168.99. Wow. So this is, I'm glad that this happened. Let me do this. And it is requesting. Okay, all right. So it is accessing it using, we found a bug over here, right? So we found a bug. Let's try doing this again though. I'm gonna turn it off from this, and then I'm gonna try to turn it on from this. And it is not. So there is a bug in the code somewhere, which I'll take a look later, right? So, but at least let me turn it back on using my IP address. It cannot. Interesting. Okay, so maybe it needs a little bit of time. So that on is also working, and it needs just a little bit of time. Okay, so let's rerun this test. So we're gonna control the devices by using the curl commands for on and off action using the category and friendly name, right? So I'm gonna choose this off action, and I'm gonna paste this over here. Then device turned off, and then I'm gonna choose the on action, but I think there has to be a little bit of wait, and that's why it is complaining about it. I'm gonna wait for a few seconds, and then I will send this request again, and it turned on. Okay, so there we go. So it looks like there is some kind of wait requirement when I'm sending the request before the switch actually registers and responds back correctly. All right. Actually, one more thing I want to show you, that if you send in a request of on to a device that's already on, it actually does not do anything. It just keeps it on. It doesn't toggle the device, but it keeps it on. Perfect. So this is how we have now built our application. And I want to quick show you this thing, one last point over here again, where, okay, there we go, where this is the Casa devices.json file that gets created. It's a huge file. So yeah, maybe I'll in future think about moving it over to some kind of easier database. When we are building a RAG application, I'm going to be sending it over to maybe a local database where I can store this, or some kind of JSON database, NoSQL database, where we can put this information in there. So going back to our architecture diagram, let's review what we did today. So we thought about adding home automation to our FastAPI server. In our thought process, we first went to the TP-Link Casa library. We downloaded it from the requirements.txt file, so pip requirements, and then we played around with it by discovering, which is kind of the hello world kind of program for our TP-Link Casa. So we did a discovery, and then once the discovery was working, which means the environment is working, we went in deeper and we wrote a whole full-fledged program where we can control the device, we can list the device, create a JSON out of it. But all of this is just sitting in your own small little project. Once you are ready, once you have ironed out all the bugs and you are ready, then you can integrate this with your API server. And the way to do this is by adding routes to your routes.py file, and those routes are then going to point towards your TP-Link Casa library that you have created in your previous standalone project. And that's it. Please let me know what you think about it. My next approach would be to create a tool, a custom tool for my agent over here, so my speech-to-speech OS assistant, and then I'll give that tool access to these three API endpoints, and then the agent will be able to control the devices as well. And while I was talking about it, I had an idea that maybe we can start creating a smart agent which can discover all the endpoints and on the fly figure out which endpoint to use, so I do not have to create a custom tool for it. I'll think more about that idea, and probably I'll try to integrate it or incorporate it one way or the other. But that would be a very smart approach where we can just give an API to an agent, right? And let the agent figure out which API it wants to use to do whatever text-based remarks that we are sending, right? So to the agent. Anyway, thanks everyone, and I will see you in the next video.